ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh and I will be your moderator for today's event, our 40th briefing room in the year 2012. Ladies and gentlemen, we're very happy to have one of the most innovative vendors in the market these days on the line today, as well as one of the most interesting and insightful consultants as well. So my name, of course, is Eric Cavanaugh. There's a slide about yours truly and enough about me. So the purpose of the briefing room, as many of you now know, is to reveal the essential characteristics of enterprise software. This is obviously complicated stuff, and we try to distill things for you, break it down in a way that will help you understand exactly what these tools are, how they work, when to apply them, when not to apply them, for example, when not to use certain technologies, and give you a good idea such that you can make smart decisions about what you buy. So what we do is we pair innovative vendors with independent analysts for a live analyst briefing. The vendor and analyst do not coordinate before the show. That is central to the whole format here because we're trying to preserve that organic style of discussion that occurs when you have a live analyst briefing. So it starts with me just kind of giving the value prop stuff. We do a different topic every month. We're in the Innovators Month right now. Next month is Big Data, then Analytics, and Data in Motion is March. That's going to be pretty interesting stuff. So complex event processing, for example, streams, database streams. You're starting to hear a lot about streams these days for good reason, and that will impact the whole integration side of the market as well, or side of the coin, I guess you could say, because let's face it, ETL is expensive, both in terms of time and money and so forth, and if you can accomplish things without moving data, you should. So innovation, we're talking about, of course, necessity, right? Necessity is still the mother of invention. And the topic today, analytic platforms, the actual title is Unity because the sum is greater than all the parts. And we're hearing all about analytic platforms these days. And the reason is obvious. If you can think about the amount of time and money and energy that people have invested in analytical solutions, and there's a lot of good insights that come out of all that stuff, but who has that truly strategic view of their enterprise and just of their analytical systems, your environment, the ecosystem? Ideally, an analytic platform should do a whole variety of things. It should help facilitate the process of analytics. It should give visibility across your entire environment, your whole atmosphere. And it should really foster collaboration, too, because if you can see what some of your colleagues are doing, which kinds of reports they're running, which kinds of queries, if you can get that strategic perspective, it can really open your eyes to understand better what your role is, what opportunities are out there for you. So it's a really integral development, it seems to me, in the whole space of information management. And of course, the other big challenge we have now is this whole concept of big data, which quite frankly is still in its infancy in terms of the tools and the methods for using them. But of course, big data per se has always been there. It's been there ever since we've had machines like computers doing things. And you can see a classic photo here of, I can't remember the name of it, the famous loom. It's one of the first, or the very first computer essentially ever made back in, oh gosh, a long time ago. Jacquard's loom, I think is what it's called. My producer is telling me. So what's happening now is we're trying to piece all these things together and get that strategic view of not just traditional data, but big data as well. And that's not a small challenge. So let's keep on moving. Krish Krishnan is our analyst for today, calling in from the Chicagoland area. Krish is very well written, as you can see, and he's also a keynote, and you can find all kinds of content involving him all over the industry. Very happy to have him online today. So Teradata, of course, is known for its analytic data solutions. It's been the big premier player in the data warehousing space for many years now, for frankly decades. And it's been doing a lot of innovation to kind of round out this environment. So we're going to hear about a couple different things going on over there and what that might mean for you. So we have Imad Birouty. He's the Program Marketing Manager for the Teradata Analytical Ecosystem. So there's that word we mentioned earlier. We're going to hear what he has to say. And with that, I'm going to hand over the keys to Imad. And Imad, just click on that slide and use the down arrow on your keyboard to move on through. The floor is yours.
Great. Thank you, Eric. Thank you for having me. Glad to be here with you in the audience. So we're going to talk about a couple things here, two topics that are different but related. One of them is we're going to talk about a product portfolio that we have called Teradata Unity. This is something we're really excited about, and fits nicely into your topic for this month of innovation, because we've got some fantastic innovation in that product. Then we'll move into a related topic, which is the unified data architecture. What happens when you merge big data with traditional structured data and SQL databases? And so we have our unified data architecture, which does that. And so we'll move from the Unity to the unified data architecture and cover those topics. So let's start first with Teradata Unity. In the data warehouse world, in the past we've seen lots of different architectures for enterprise analytics. And the architecture that we continue to advocate, that we think has the highest value, highest business value, lowest TCO, highest business value, is to have a centralized, unified data warehouse environment. It allows you to do cross-functional analysis, have all your data in one place. That continues to be the gold standard for data warehouse analytics. But knowing that sometimes one system is not practical, we have what we build out and we call the Teradata Analytical Ecosystem. This is part of the unified data architecture. So sometimes we see customers who may want to build a data lab, a sandbox type environment that's non-production data within their integrated data warehouse. Or sometimes we see dependent data marts built for specific purposes, maybe a special purpose application, or maybe as a deep history archive or data mining archive or an independent data mart. And one of the popular architectures we see is a dual system for high availability. So building a second system to fail over and provide continuous operations. So we look at this and we call this the Teradata Analytical Ecosystem. And it's not just piece parts, but what we do to bring it together as one ecosystem is we wrap it around with a lot of intellectual property and value add. Some of those things are what we call Viewpoint, a portal-based monitoring environment. We have our 24 hours support organization, and then Teradata Unity. Unity is what strings together all these separate systems and makes them operate as a single analytical ecosystem, presenting the user with one interface to the entire environment and making all the IT infrastructure behind it transparent. So it provides a interface for the users, and it also helps the administrators run and monitor and manage the environment as if it was one. So in doing that, bringing all this together, what we're doing is providing diverse analytics to the whole set of users, business users. So you got your business analysts, customers, partners, marketing analysts, executives, and even real-time decisioning, what we call active data warehousing, real-time decisioning to frontline workers who are making decisions on the spot, and operational systems. So very real-time analytics. This is the analytical ecosystem that provides analytics to businesses through traditional database SQL interfaces. And in doing that, in having multiple systems each tuned to a specific purpose or specific application, maybe high availability or anything, there's a lot of benefits that come with that. We can help companies meet their service level goals, having the right data, right place at the right time. We can monitor that, track for application readiness. Is the system ready to accept my query? And we can help companies match their application, the characteristics of that application and its workload to the right platform, and have investment protection as data and applications migrate across platforms. And of course, one stop for support and service. So there's a lot of benefits to the analytical ecosystem. But in order to realize that, you have to string it all together. You have to bring it together and make it easy for users and easy for administrators to manage. And we have here the Teradata Unity portfolio. It consists of 4 products. Unity Director, Unity Loader, Unity Data Mover, and Unity Ecosystem Manager. And each has its purpose. There's lots of functions that you need when you have multiple systems acting together as one. We'll take a look at the first two in this session, and but to give a brief overview of each one, Unity Director is everything SQL. So any SQL commands going to your data warehouse environment, whether you're updating data, manipulating data, retrieving data, modifying database objects, anything that's SQL-based runs through Unity Director. It's intelligent. It understands the data dictionary, the structure of every database that you have out there, and it does work for you transparently behind the scenes. Then we have Unity Loader. Unity Loader leverages all the intelligence of Unity Director and applies that intelligence to bulk loads. So you can take your bulk data loads, feed them through Unity Loader, and it will automatically, by itself, determine where does that data go, which systems, one or more systems, and make sure that the data is loaded to each system. Then there's other times when you actually need to move data between systems, and that's where we bring in Data Mover. It's an intelligent tool that allows you to specify your intent. I want to copy my customer table from system A to system B. You give it the command, and it determines the most efficient and appropriate method to accomplish that. And then Unity Ecosystem Manager gives you end-to-end control and monitoring of processes and components and data, the currency of data. So it's a very complete portfolio of all the functions you need to manage that environment. So let's look at Unity Director first. Unity Director is going to present the user with transparent access to their systems. And so there's a couple different ways as administrators you may want to route users between systems. So one is what we call controlled routing. This is where you can specify a particular system that a user's query is going to go to. And so you can have a named system, you can have a preferred set of systems where there's a pecking order to go through. And this is great because it gives you full control as to which system you're going to divert that user to. So for high availability failover solutions, that's a good option. The other one is automatic routing. There's no rules required here. This is where Unity takes a look at the SQL query that's coming in, parses it, determines which objects you're going after, and automatically routes your query to the system that has the most up-to-date data and is going to process that query the fastest. So it's really hands-off, very intelligent. And all of this is enabled through our patented SQL Multicast technology. So we're talking about innovation. This is an innovation. This is a patented SQL Multicast that allows your SQL to be parsed and distributed to all participating systems that are actually affected by the query or participating in a query or an update. So really good stuff here. And again, it shields the user from any complexities. Then on the other side, on the flip side, you have updates happening. User may submit updates. IT organization may submit updates. We can keep systems in up to date, and again using the SQL Multicast technology. So we have different methods of doing that. The default is let Unity update the data wherever it resides. It knows where the data is. If you're going to update it, it'll update it on all the systems where it resides. You may have situations where you want control of this. So if you have a tool that modifies tables or creates temporary tables and you want that to happen on only one system, we have a method to do that called create preferred. And if you want to rotate that function, rotate that burden across systems, you could do that by alternating across systems in a round-robin fashion with a method we call create balance. So Unity Director is very intelligent. It's a front end to all SQL commands, whether it's users querying the system or doing SQL updates. It gives them a transparent access to everything. Then you have Unity Loader. It's going to use the SQL Multicast technology again to allow you to distribute loads across your systems. So we bring in a Unity Loader. You can have multiple servers for availability and throughput. your loads are not directed at any Teradata system, but rather those loads are directed to the Unity loader system, which then takes those, opens up your data loads, looks at them, and determines what data are you updating and which systems have that data, so I can send the updated versions to that system. And it does all the checking and validation that all of the loads completed successfully. And doesn't just work in a single site. If you have multiple sites, those loads will actually be streamed over to a second site and loaded locally at the second site as well. So it gives you a lot of throughput, a lot of flexibility in your design, taking the complexity away from system administrators to have this multi-system environment. And literally, with single commands, you can affect multiple systems. So that's where we say little to no additional effort for IT administrators to have a multi-system environment. That's a lot of innovation right there. So Teradata Unity brings all of these together, brings the systems that are running the Teradata database together, brings all the value that you get from a multi-system environment without having the complexities and the drawbacks and the additional effort that comes with managing a multi-system environment. So it gives you the benefits without having the burdens and the limitations. So that's managing a traditional Teradata environment where your data is structured data, fits in rows and columns, and can be acted on with standard SQL. The world that we're living in has evolved, and it's not just about structured data anymore. We have multiple types of data. We have multi-structured data in the form of text, audio, video, weblogs, social data, machine data, all these things coming in that need analysis. Their volume, their velocity, and is very high. And when those are merged with traditional analytics, you need to have the same type of control. You need architectural flexibility. Here's where we introduce our Teradata Unified Data Architecture. Unified Data Architecture brings together all the functions that you need. And so here on the right, you see the orange system there for traditional structured data and analytics. But there's other needs that come up. When you're dealing with multi-structured data, when you're dealing with non-SQL analytics, you need two types of additional functions. You need a discovery platform. You need somewhere where you're going to do analytics on the big data. You're going to comb through it, find useful pieces of information and data, and act upon them. And sometimes that requires functions that are beyond what SQL is capable of. But the problem we have is not all our business users are capable of writing their own programs in third-generation programming language. You need a way in these discovery platforms to present it to business users that know the language of SQL. So you need some type of discovery platform to understand the value of the data. And then you need some type of big data management. You need a way to capture all of this data that's not all useful, and I'll use the term non-data warehouse worthy data, right? So it's a lot of data. You don't know which of it is valuable yet, but you want to capture it and store it for some period of time, maybe for a long period of time, until you can extract the data out of it. So the discovery platform and what we bring to the table is the ability to bring in data from non-relational data, relational data, multi-structured data, bring all of those into a single system, and to be able to do all types of analytics, SQL-based analytics, non-SQL-based analytics, Mapreduce functions. These discovery platforms are to find those nuggets of information. This isn't a production, mission-critical 7x24 system. This is actually where data warehouse was 25, 30 years ago. This is a discovery, finding those nuggets of information with robust tools. And those tools are presented to users who may be business analysts that know the language of SQL, maybe data scientists that want to go beyond SQL, using Mapreduce and statistical functions and math functions and third-generation programming languages to go after the data. So the discovery platform is going to feed that purpose. And for the big data management, what we see a lot of customers doing is using Hadoop to fill that gap. And knowing that, we went out and we talked to 20-plus customers to understand how they're using Hadoop, where it fits in their environment. And so what you're seeing here comes directly from customers who are using Hadoop. And what we found are some patterns of usage. And some of the ways that they're using it is as a landing place for data that's extracted from operational systems. So rather than extracting data from your operational systems multiple times, extract it once, persist it in this Hadoop environment, and then from there you can pull it and distribute it out to as many systems as you want, as many times as you want. And in some cases, customers are choosing to take that extracted data and hold it for long periods of time. So they're keeping like long history. This is not backup and restore type data. This is not a backup, but rather they're taking those extracts from their operational systems and holding on to them for longer periods of time. We're seeing customers do pre-processing on the data. So they're going to take that raw data and they're going to manipulate it and put it into usable formats. So one of the common ones is take web logs and do sessionization, sorry, easy for me to say, or removing XML tags. So they're taking this data and that's raw web logs, not sitting in rows and columns, and extracting pieces of information out of it that they can then use in their database. They're doing transformations on the data. Sometimes those are light transformations. Sometimes those are custom transformations that they have to hand code in Java or other languages. We're seeing some exploration where they're looking at at the data and doing some very light analytics, batch scoring, and even some single subject reporting. So not heavy-duty analytics is what we're seeing. We're seeing storing, managing, manipulation of data prior to analysis. So with that, knowing that these needs are there, we filled those gaps. And so we could take those cylinders that we're looking at here, those systems, and put names to them. Where the traditional database SQL analytics are handled with the Teradata database, we have our discovery platform, the Teradata Aster Big Analytics Appliance, that allows business users to do Mapreduce big data analytics through standard SQL. So coming back to innovation, we have patented SQL Mapreduce technology. And what this is a business user can use standard SQL and submit queries. Those queries in the back end are interpreted and run as Mapreduce functions against big data, large data sets. Right? And those could be anything you want, any type of non-SQL analytic running in the background, submitted through standard SQL. And then bringing in Hadoop in there. Bringing Hadoop into the mix as a big data management environment. So it's used to both capture, store, manipulate, refine the data, so it becomes both a source and a target for data. So it can be used as a data hub to feed data to these systems. And the environment, this architecture is not a static architecture. It allows for flexibility. So let's say, as we see in this picture, let's say this big data that you're looking at and working with can be stored in one of the two environments here. Maybe it can be stored in a Teradata warehouse. We have platforms that are what we call extreme data appliance. It allows you to handle large amounts of data for a very cheap price per terabyte. So but still access it through the Teradata database, or store it in Aster. That flexibility exists. So in this case, you get the benefit of having all the different types of analytics, but eliminating one additional system from sitting on your floor. Further, another variation to this architectural flexibility is, let's say you actually really do want Hadoop in there. You really need it for certain functions. We have the ability to actually marry the two together, have Aster and Hadoop together in one system. So now you're getting full Hadoop, full Aster together, but rather than having several systems spread across your environment, actually house them within the same system. And we do that with our Aster appliance. We just released this. We call it the Teradata Aster Big Analytics Appliance. And it is a first. This is an industry first because it's not just a packaged Hadoop appliance. This is actually packaging together an engineered and packaged environment that gives the Aster database, which is going to give business users SQL access to Mapreduce capability, packaged along with full Hadoop running Hortonworks distribution on here, and putting them in the same cabinet. So you fully supported cabinet, has full systems management, phone home capability, diagnostics, and all of that, fully supported. So this is the first in the industry, marrying those two types of functions together in one product. And we mentioned the SQL MR technology, the SQL Mapreduce technology. The patented technology allows the business users to use standard SQL for Mapreduce functions. But we go beyond that. We have a feature called SQL H that we've worked closely in engineering relationship with Hortonworks. And what this does is you have your big analytics appliance that runs both Aster and Hadoop in there, and they run on the same interconnect, what we call the BiNet fabric in there, and they're running on the same one. What if the analysis that you're doing needs data that's sitting on the Hadoop nodes that are within your environment? Well, whether those Hadoop nodes are inside the cabinet or even in a separate system, our SQL H capability allows the user at runtime to submit a query that uses data that's sitting out in a Hadoop system. And we can read the H catalog, determine where those objects reside, go out, grab them, run the analysis either on Hadoop or bring the data back and run the analysis on Aster, and at runtime incorporate this data that's coming from Hadoop back into Aster. So it's real-time access to data within Hadoop for analysis within Aster. Very flexible. We're really proud of this solution. It gives a lot of flexibility. It's marrying these environments together to make access transparent and simple for users, so that users can get value rather than try to just figure out how the technology works. Then to wrap it around, earlier we talked about the ecosystem, and we talked about the wrapper of Viewpoint and Unity and support around it. We're doing the same thing here for the unified data environment. These are not just systems sitting on the floor. We wrap them around with the ability to manage and support the environment. We have our product called Viewpoint, which is our web-based management portal that goes across systems. It allows you to manage systems, monitor queries, the health of all your systems out there. We've taken this capability and we've extended it out to Aster. And so we have portlets that are specific to Aster, and we have portlets that are shared. They'll actually run for both Teradata and Aster because they have similar functions. We're bringing the same capability to Hadoop in early 2013. So we're really wrapping this unified data architecture environment in all the intellectual property that we have to deliver a full solution. And then support on the same way. Our Teradata Vital infrastructure. This is the management and monitoring of the actual system. So we're collecting events, correlating events, finding faults, detecting and pinpointing faults, and doing phone home to the support center, 24 hours a day, fault-tolerant support center. That's all in there. We're able, through this Teradata Vital infrastructure, to get up to 70% of any faults, capture them, and determine the cause of the fault and escalate them, automatically creating incidents for them. So very, very powerful stuff. So bringing this back around here as we close, bring this back around to where we started. We started talking about the Teradata analytical ecosystem, where you have the Teradata database running traditional SQL and database analytics on multiple systems, giving value to the users that we associate with these business analysts and others acting on structured data. And when the needs go beyond that, we're able to grow out this environment with the Aster and Hadoop platforms, integrate them in with the rest of the analytical ecosystem, and serve additional users, the data scientists and the engineers who want to work with third-generation programming languages. They want to work with math and statistical packages, bring all those into the mix for a full environment. So that's my piece there on the innovation, the Teradata Unity, and the unified data architecture.
Very good stuff. We had a lot of good questions coming in already. So, Krish, I'm going to hand the keys over to you. And while you're doing your presentation, Imad, you can just take a quick glance down there and see what's going to be coming down the pike. But, Krish, I'm going to hand it over to you.
Sure. Thank you. Thanks, Imad. That was definitely a wonderful insight. Real quick, before we jump into more of a Q&A discussion, I'm just going to set the stage, for you to understand where I'm going to divert our questions to or our thoughts to. So if I heard you correctly, in terms of how you viewed the world, this is exactly how the data analyst view of the world is today, right? I mean, it's like Lego building blocks of data pieces of all sizes, kinds, and you could pretty much deal with any kind of questions you have and get insights. So that is at least where the promise is heading towards, and this is exactly where enterprises feel that data is sitting. Now, if you look at it from a decision support perspective, so if the executives were to look at what are all the data pieces and parts that they use in decision making, most of these blocks form some kind of inputs into a decision making process in the organization. Now, some of this is relatively new to large organizations, like machine data, for example, is something very new to large organizations. But for a company like an Amazon or eBay, that data has been their bread and butter for many, many years now. Scientific data is very new to a lot of organizations who are looking at reducing cost for heating and cooling of the buildings, for example, a very simple business case. But if you look at a company like Train, that data and that model is something that they've used forever to determine how to improve efficiencies and how to reduce operational costs. So looking at corporate decision support platform, and based on what you explained on the unified architecture approach, there seems to be a lot of overlap, if you will, in terms of where the industry is heading and what Teradata is coming up with as a potential, if you would, groundbreaking approach to solving the data problem within the enterprise. But I think the issue that is largely going to hurt a lot of companies is the fact that data is distributed, like how I have put in a very simplified picture here, and it's distributed across multiple geographies of the world, and sometimes it is the same data that is shared across multiple areas and replicated, and there is a lot of pain in replicating the data. And going to the initial portion of your discussion, I believe if you are on a Teradata family of products, you have a solution to handle that pain point today. So that means that somebody who is a DBA, for example, doesn't have to sit around and worry about looking at TASM, looking at governing runaway queries, looking at diverting ETL jobs to have more priorities and things of that nature in a large data footprint. They could simply have this unified architecture approach and Unity as the two supporting platforms, if you will, to make better infrastructure management and then make better performance SLAs and deliver better performance results. Now, here is a workload picture that you discussed, Imad, and this is the way I'm viewing the world today. And here is where I would like to start asking some of our questions. And I would start it off, and then we'll pick up a few of the audience questions too, I believe. The larger portion of our workloads that consumers have expressed, right? I mean, people who consume data every day, who are the business users, have seen and expressed, lie within the fact that to the user, they're asking a simple question from a report, and then the database is slowing down. If you ask the database administrator or the solution architect, to them it is basically that they've got the best possible referential integrity architecture laid out on a data warehouse, and it is potentially the bottleneck of too many users asking questions on the same database, and obviously not being able to give enough, speeds or throttles to multiple different users so that everybody is serviced at the same time. So if this is a situation, and let us say I have a dual active system and I am a Teradata client, can you explain real quick how Unity would help, alleviate that problem at that juncture? Like how would it control this so that everything here looks more green as opposed to being more red?
So Krish, what it will do is it'll actually do some load balancing, real-time load balancing. It looks at the depth of the work queue on each system, and using that, it also looks at the incoming work, both the reads and the writes, and looks at that and says, okay, I have a read coming in, and System A and System B, either one could handle this query and has the data to handle it. Which one is most up to date based on the depth of the write queue and how busy based on depth of the reads, and it will load balance. It will send to the least busy system with the most up to date data. So it's going to do load balancing on here. Was that answer to your question?
Yeah, absolutely. So that's one part. So if I heard you, so the consistency of the systems will be something that will be maintained outside. So the user or the DBA doesn't have to worry about the consistency. The system actually would automate that consistency update, and it would manage the consistency. That, to me, I think that is the biggest, win, if you will, right? Because now you're actually able to take an ACID-compliant database, and you're almost mimicking, a NoSQL kind of a behavior where you're saying eventual consistency is fine as long as availability and partitioning are addressed. I mean, in a broader sense. So I think that definitely is a groundbreaking direction. So I think that answers that question. Now, from a workload perspective, the biggest issue that I have run into with a number of users expressing, concern is that they have no idea about what is the data that they're getting, right, in a mixed workload situation, and they don't know what are the formats or the volumes of the data that's even coming. So this is, I think, more speaking towards the unified architecture, if you will, right? I mean, looking at unstructured data, big data, semi-structured data, web logs, and things of that nature. So if you have no idea of what is coming in from a workload perspective, how would somebody be able to, meet some of these workload requirements where it is, for example, a fault-tolerant architecture, right? I mean, if I'm bringing in a large amount of web logs and I'm running it through an big data analytics box for a simplified, situation, what kind of a fault tolerance is available in the, architecture today that is going to make sure that the process runs end-to-end? I mean, is that something that is addressed as a part of the unified architecture, or is this something that would be a customized configuration that somebody has to do? How does that work?
Yeah, that's a good question. So with the Teradata environments, Unity takes care of that. It provides all the fault tolerance, failover, redirection of users, redirection of ETL and data loads, and preserving and protecting data loads and replaying them when systems come back up. So in the Teradata environment, Unity handles all of those 100% and all transparently, automatically. In the unified data architecture, that's where we're building towards. You can have multiple Aster systems or the Hadoop systems. Building the fault tolerance on those would be more custom solutions today. Where we're going tomorrow is that these will all come under the control of Unity to provide that same robust capability to Aster and Hadoop as well.
Well, that's awesome. So that means one of the things that I think I've heard repeatedly, and I would like to see it as an architect myself, is that the interchangeable components in the infrastructure, right? I mean, for example, I could bring in one of the products from Teradata today and deploy it. Say, for example, it is a mid-range appliance, and then 6 months down the line, let us say that there is a legacy 5550 that is retired, and there is a big data appliance that is in its place. the interchangeability of those infrastructure components is something that is more of a plug and play. So you can actually do this in a modular fashion as opposed to a big bang approach. Is that correct?
That is absolutely correct. Yeah, because they're all running the Teradata database, the same exact Teradata database, you get full portability of data and applications across them. So that is absolutely correct. Mm-hmm. Yeah.
Wonderful. So then that, to me, I think is what is where the rubber meets the road in terms of isolating the workload. In terms of how I would visualize it to something similar to what I'm showing on the screen, is where a number of users will start with, right? So you have your EDW, you have a bunch of data which is transactional and third party, and then you have a whole bunch of unstructured. So I think if somebody is going to do this in a very modular fashion, you start with EDW, and then you come back and you plug in like an Aster appliance, and you do things like third party data or application data or things of that nature, which is a lot more easier to analyze out of the box, on an unstructured platform, and then you start bringing in more of the Hadoop layering, so you actually compartmentalize and, you divide your workload. So I think that makes perfect sense. Mm-hmm. So one quick note that I would like to add to understand one process better is the homogeneity and the heterogeneity of the platform, right? I mean, this is primarily geared towards supporting Teradata databases across the realm, and then the big data appliance comes in because of it being, having Viewpoint and the Aster appliance built into that box. So Hadoop gets in to the mix in an indirect way. So it's not a direct, Hadoop distribution support that we're talking about when we talk about heterogeneous platforms, but rather it is, whatever you're building into that big data analytics appliance box, right?
Well, if I understood you, Krish, the Hadoop servers that we sell that are packaged into the appliance are supported. So we support not only the hardware, but we have a relationship with Hortonworks where we take calls and on the phone and do support for the software as well.
That. Okay.
Yeah. Mm-hmm.
Wonderful.
Yeah. Yeah.
Wonderful. So that basically gives a complete perspective in terms of how you handle workloads. Now, how would you evolve this towards your next generations? I mean, you spoke about it a little bit, so if you can throw a little more light on it, and then we can turn it back to Eric for further Q&A, that'll be great, because I'm looking at this like this is 2012. You evolved, from where you were a year ago to where you are now, and that's a huge leap, in terms of what you've done technically, right? So how would you see this continuum moving forward from innovation perspective? Can you throw a few minutes on that?
Sure, and that's a good question. We have our ideas, which which I'll share some of them with you. But to preface it first, that we first have to make sure, before we deliver products and solutions to market, that what we're doing is something that the market wants. And the reason I say that is that when we were talking to those customers about Hadoop, they have a completely different view of the data that's being stored there than what we're used to thinking of when we think of databases, and both for decision support and transactional systems where everything has to be backed up, everything has to have certain service level agreements. Their attitude towards the Hadoop systems was that, well, if it dies and I lose all my data, whatever, that's okay. Do you back it up? No, we don't back it up, because if we lose it, we lose data, we don't care. So they have a very different mindset on what they're using. So what we don't want to do is force a view of high availability and data protection and everything that the market doesn't value. So I just want to preface it with that. We just have to be careful what we're doing there. But our belief is that the market will evolve. These tools will evolve, and customers will eventually start using all of these in more mission-critical environments. And it's going to take years to get there for them to view it that way. But when they do, we have some very interesting ideas. So you take You take the Aster solution. We said that that's SQL based, so it's standard SQL for the business user. So what we could do is we could take that and put the Unity front end on there. So now users are submitting queries, and they submit the queries and put all the arguments in their query, and based on that, whether it's a query that's going to go to a Teradata system or to an Aster system, here again, the user doesn't need to know. They just want their data. We take care of it, route it, and get it to the right place on time. And also, getting to data management. You have your Aster system, you have your Teradata system, you have your Hadoop system. One of the features of Teradata Unity that we didn't go into was the data mover piece of moving data between systems. So what we've got our eye on is the ability to take the intelligence of data mover, where you say, take this data and move it from one system to another, and then in the background, data mover figures out what is it that you're moving and what's the best way to move it. Take all that and have it move data among the systems, from the Hadoop to the Aster, Aster to Hadoop. We already have connectors to access data, but this is more of the data movement and placement and copying between systems. Then we have another feature that we didn't talk about, which was the ecosystem manager. This gives you the end-to-end process control. From the minute you access a piece of data, as it flows through your entire ecosystem, through your ETL tools, the hardware that's running the ETL servers, the ETL processes that are running to load very specific tables, and the queries that are going to come and access those tables. We get that end-to-end view of every piece of every process that has to run to give a user their reports at the end. So we can take that intelligence, that end-to-end intelligence, and wrap that around into the Aster environment. We could wrap it around to the Hadoop environment, so we can watch data coming in. We can track the placement. We can track the consumers of that data. We can do all that end-to-end process tracking and be able to take action on it. If one of the components is down, if one of the components doesn't have the latest data, we can do we can have the ecosystem manager take action and do things with it. So we've got a big bundle of thoughts on where we can take this, where we want to take it, and we are, the wheels are in motion, but we're not going to deliver anything to market before we think the market is ready for it. Yeah.
Sure, fair enough. Yeah. Mm-hmm. So, Eric, over to you.
Mm-hmm. Okay, good. And we have a lot of good questions here, folks. So thank you so much. Let's see, I'm going to go ahead and grab back control of the WebEx real quick, just so I can show a slide. So one of the first questions was about Unity, Imad, and let me try to bring up this. Here we go. So one of the questions comes from an attendee who asks, is the platform, the Unity platform, a middleware solution or client-facing? It seems to be missing some business view definition capability, metadata, basically. Who does use this stuff? Is this a business user who can use it?
Yeah, it's actually a combination of client-facing and middleware. So the user will, if Unity was not in the picture, users would connect either directly or through an application to a specific Teradata system, right? They would, their application or their BI tool or just their SQL tools would connect directly to an IP address where the Teradata database is running. And what we're doing is we put Unity as a proxy in between the user and the Teradata database. So the user is actually interacting directly with Unity. They are connecting to Unity, but they don't know it. When they're connecting to Unity, it looks to them and to their applications as if they are connecting to a Teradata database. So they are connected directly to it. So in that sense, it's client-facing, but it's not a client-based tool. It doesn't have its own GUI for users. It is the access to the Teradata system. So in a sense, it's client-facing, but it plays a strong middleware role. And I think there was a second part. I think you mentioned something about the metadata.
Yeah, metadata.
Sure. So Unity, and this is part of the patented technology. What it does is it actually reads the data dictionary of each of the systems. So it knows System A, System B, System C exactly what the data dictionary is. It knows what tables exist, what views, which macros, what user permissions are there. It has and maintains a full copy of that. Unity's copy of the data dictionaries of all the systems is maintained on the fly. So it reads it in, keeps a copy, and as you make changes, it maintains its own changes. So with that, and if you can imagine now a Unity server that has copies of multiple dictionaries from across systems, it can now use that when it's routing queries or routing updates. So a user submits a query. Unity takes that query, parses it, and says, okay, you're looking to join the customer table with the transaction table, with the inventory table, this and that. And it looks and says, where do these objects exist? And it compares those to its copy of the dictionary and says, well, System A has all those, can satisfy the query. System B also has those, but System C doesn't. So let's eliminate System C from the mix and send it either to A or B, and then it goes through another round and says which system is most up to date and processing data faster, and we'll send it to the system that it thinks is going to return a result to the user the fastest. But regardless of which system it sends it to, it will always maintain a consistent read. Regardless of which system you go to, you will always get the same result on there.
Yeah, that's very interesting. So let's talk about semantics. I mean, if I hear you correctly, you're talking about sort of a living, breathing metadata management layer that Unity is running. What kind of semantics capabilities are incorporated, and in terms of ontologies, what do you have there?
Yeah, so if we're talking about semantics as in a semantic layer, or what we call the access layer, building views or fact tables on top of the base tables, all of that is transparent to Unity. So so the user will submit their query referencing a view or other fact table that's in the system. That passes through Unity transparently because it knows which systems have that, and then it's up to the Teradata database to determine, do I want to go against a view? Do I need to do a full table scan? Where am I going? What do I want to access an index? Teradata database does that, but to Unity it's fairly transparent. It has a copy of the dictionary, it knows where these things exist, but then the database determines what to use and what's the best access method. The optimizer will do that at runtime.
I guess then my question would be, as you are loading in different systems, loading in different information sources, basically, when you said Unity Loader will scan the existing tables, the embedded dictionary, et cetera, then what kind of dynamic mapping does that do to other systems? Because you'll have some cases where it's very clear that this column in this database is the same as this column in this database, but then you'll have some of these fuzzy areas. And can you, as a manager, go in and validate, yes, this is in fact the same as this, and have some fuzzy logic around that?
Yeah. Okay. That's a good question. So, in the current releases of the Teradata Unity products, it assumes that the tables are the same across systems. So, if you have a customer table and it has your last name, first name, address, it assumes that the same customer table on system B has the same structures, the same columns in there. In the future, actually, we're going to remove that limitation in there. But today it assumes that they are the same. In cases where they're not, administrators still have full capability to go in directly against the Teradata system and load and manipulate data outside of Unity. That capability still fully exists.
Okay, good. And here's a really good question that just came over the transom here. One of the attendees writes, does Unity read SQL hints to help it route queries properly, such as must use governance-approved data rather than the most recent update, need a fast result rather than from pulling from a server or another contingency, etc.?
That is a good question. It's kind of an NA question. It doesn't apply because in the Teradata database, we don't use and don't have the concept of hints. That's something that's not a limitation. That's something that as a design principle we don't support. We think that the database and the optimizer have to be smart enough that the DBA or whoever's writing the SQL does not have to add hints to it. So Teradata database inherently does not support hints. In fact, just kind of a quick aside, anytime anyone in here within the company has any idea or bright idea that says, yeah, we can add some type of hints or any type of intervention from the administrator, there's heavy pushback. Our philosophy is that the database and the optimizer need to be smart enough to pick the right access paths for that no hints allowed.
That's very interesting. Okay, that's some good granular detail for you folks.
Yeah.
Okay, good. And so we talked a little bit about security. We have a couple different questions around security. How do you protect certain data sets? How do you execute the basic kind of security questions and legal, like legal discovery type issues? Okay.
Let me give you an answer based on what I think the question is asking. So within the Teradata database, you have all your standard security controls. So you have all your locking, all the rights management, all the privileges in there. So those are built into the database and which users can access which objects. Now, in a multi-system environment, we strongly recommend that all this authentication goes to an external authentication like LDAP or Kerberos, because you do have a multi-system environment. It's easier to maintain, for administrators, easier to maintain all of those in an outside system. And the database will then reach out to the authentication server and determine, does this user have rights over here or not? And so, but again, inside the database are full security controls, access rights, privileges, and all that.
Okay, good. And let's go ahead and jump over to the unified data architecture again. You had a number of good slides in here. And if I heard you correctly, I thought it was very interesting. You were basically saying that you're trying to listen carefully to what you're hearing from customers and I'm sure prospects as well. But you're trying to be, I suppose, cautious in terms of how much time and effort you put investing into how thoroughly you can connect these two worlds of structured data and unstructured, because it's all still fairly nascent, right? I mean, and I kind of heard you saying that what you're hearing from a lot of customers is they are largely using Hadoop as sort of an augmentation to an analytical sandbox to kind of play around with ideas. And is that about right?
That's exactly right. And so for connectivity, we want the connectivity between them to be as robust as possible. And on that, we're delivering on that. So we have connectors between every combination, Teradata to Aster to Hadoop, every combination in there, we do have connectors that data can move over. We have the SQL-H between Aster and Hadoop that can reach over and grab information on the fly. We are adding that right now to the Teradata database as well. So at runtime, reach over to the Hadoop. So from connectivity perspective, we're building as robust and as fast as we can on that front. When it comes to things like high availability and mission-critical computing, those things, that's where we do want to deliver, and but that's where we need to be careful, because from what we saw right now today, that's not features that our customers would value. So if we came up with a super way to do backups on Hadoop, there wouldn't be any interest right now. If we had a dual active environment for these, the interest just isn't there right now. We think eventually it will be there. It's just a matter of time. It's going to take multiple years, and when that time comes, that's when we want to deliver it. We don't want to deliver something before users care about it.
Okay, good. And of course, when something has become an appliance, you know that it has reached a certain level of maturation in the marketplace, right? It's kind of like a coming-of-age thing anymore with appliances. And just so people understand, if a company goes out and buys something like this, what else do they really need to have in their organization in terms of other applications, other tools, other frameworks in order to really be able to hit the ground running and do something that will provide business value, ROI, with something like this?
That's a good question. That's a good question. So the idea is that when these are delivered, they're ready to hit the ground running. So they're fully engineered, packaged, and delivered, ready to go. With the Aster portion of this, the companies don't need anything different than what they already have. So any method or tool to access the data through SQL. So if they just have a SQL front end, if they have BI tools or applications, they're fine. They already have everything that they need. If they are using the Hadoop portion along with it, if they plan on accessing the Hadoop through Aster, we have the connector there that comes with it, so they're all set there, nothing else to get. If they want to access Hadoop natively, then they will need a Hadoop programming environment, and so those are all open source, and they can get those. So, and if they want any tools to develop like Java or C++ or Python, they would just have to procure the licenses for those. But most likely companies would already have that, as the data scientists and others would have those. Okay,
good. And here's just kind of a curveball question. So one of the things that we're seeing out there is that people are using these open source environments and what you're talking about here with this appliance as a way to store lots of non-traditional data, basically. It's not the sort of structured stuff that we typically see in a data warehouse, for example. But what are some interesting examples? Like, just off the top of my head, I'm thinking if you're a mid-sized business and you have one of the older ERP systems out there, is there a way you can just pull out all kinds of other data from an ERP system that you're not normally pulling, like some of the log files and machine-generated data and some of that kind of stuff, even if you can't use it now, just to kind of start that process?
Yeah, I'll give you actually two examples, and these again came directly from our customers, and I won't mention the customer's name to protect their privacy. But one of the customers we were talking to, that they had a group of data scientists and business analysts together in one group, whose charter was to find new insights into data, and they were running against the Teradata database, they were running against their Hadoop environment, and they were using a combination of all of these things to find insights. Once they found those insights, they would then promote this data to the Teradata database, where it becomes quote-unquote production. And what they found was that the data scientists were actually taking the data out of the warehouse and trying to reverse engineer it back to its original form. And the rationale was by already parsing out the data and having the only select pieces come out and stored in there, you've limited my creativity, you've limited the insights that I can get. They say, just give me the raw data, let me figure out what's interesting and not interesting, and then I'll tell you which pieces I want you to pull out. So that was an interesting one, very much discovery, and very much where they say, give me everything, and I'll determine what I think is valuable and useful. That was one. Another one that's interesting is another company is a business-to-consumer company, and they are generating 8 terabytes of data a day. And of that, they're storing it, and they're storing it in Hadoop, but the majority of it is data that again, I'll use the term non-data warehouse or non-EDW worthy. And what they're doing with those 8 terabytes, they store them in Hadoop, but then they, every night, they boil it down to only 150 gigabytes out of the 8 terabytes, 150 gigabytes of data that is EDW worthy. And they'll take that data and then promote it, put it into the warehouse for analysis by their business analysts. So those are two good, kind of interesting ways that customers are using that, the large amounts of data and then not using all of it.
Okay, that's great. These are real good questions. We'll just give you a couple more and then we'll wrap up. So one of the attendees asked, can you speak to the SaaS relationship?
Okay. So the SaaS relationship continues on. It continues on. We still have a working, healthy relationship with them. You can still access the SaaS data, import it into Teradata. You can still access the SaaS analytics, and all of that's still there. Not sure what else to say. Everything that we've said before continues on. SaaS is their own company. Teradata is our own company, so we continue to improve our products, but the relationship is still together.
Okay, good. That was a tough one.
Yeah.
Just because I thought, I'm like, oh, did he mention something? And then I'm like, I don't think he mentioned that. It's a good question. All right, one last question. This is the big. I even said in the Q&A, it's the $64,000 question these days.
Yeah.
What are the qualifications for a data scientist?
Yeah, and that is, and you ask 10 different people, you can get 10 different answers. But in general, we view the data scientists as those employees who are analytical in nature, and they have skills that go beyond SQL. So many of them are programmers, whether they're deep programmers or just use scripting languages, but they go beyond SQL, and they also, in addition to these technical skills, understand the business that they're operating in. And so they're going to use a combination of all their skills, whether it's third-generation programming languages, scripting languages, SQL, and all of their technical skills, marry those with their knowledge of the business to try to discover new insights. And so these are insights that no one else has seen before. And once they do that, what we've seen is that they then work with the business analyst to say, I found an interesting nugget of information when you look at this, this, and this. You take it from here and develop it into something that can become production and analyze it further, on a production basis.
Yeah, that's a good
That's
answer.
kind of a long-winded answer.
Yeah, well, certainly it's going to be a very, very hot topic for years to come. And maybe, Krish, if you're still out there, what are any comments you have on how to find a good data scientist?
That is a tough question in itself, Eric. But I think, business experts, who've been in any company for a long time, they know the data well, they know the business well, and I think they are kind of a pseudo data scientist today because they'll be definitely using, the data from a database into Microsoft Access or Excel or some other, environment, not just within the data warehouse or within a database or any tool, and they'll be doing a lot of, what if and formulations and things of that nature. So I think those people are very close to becoming what I would call the next generation of data scientists who can think about the business outside the box. And where I was going to draw my comment to was basically what Imad said in his presentation earlier, and I alluded to this a little bit, is that by creating a data-driven architecture, I think, you're going to enable users to start focusing on data and not worry about how it is serviced, where is it serviced from, what does it take to make something work. So you're removing a lot of the technical puzzles from the equation. Thereby, it becomes a lot more data-driven architecture, data-driven adoption to users. And I think definitely, this architecture is where everybody is going to evolve in the next few years. So definitely this is next generation, and this is leapfrogging, and this is what a data scientist will want, or at least an organization that wants to compete in the new world will want this kind of an architecture. So if you try to build this on your own, which I know a few of the folks out there in the world have done, protecting the innocent, I'm not revealing who or where, but I know a few folks who tried to do this by themselves, and they've kind of learned the hard way that it is not easy to go after a computing fabric and do this yourself. So I think, going with a vendor, getting the support, that definitely is impressive. What Imad is saying that Teradata is doing and planning to do is definitely impressive, and I think for Teradata customers, it probably is going to leapfrog them on that architecture. So definitely, Imad. So I think that you gave a lot of answers which answered a few of my questions, and I think a lot of questions that the folks threw out. So I know that a number of things are under NDA, so neither can I say it, nor can you say it, nor can Eric, but I guess next year is going to be startling with a lot more innovation. So we are looking forward to hearing more from you and Teradata in the next year.
Sounds good. Thank you.
That's great. So thank you so much, Imad Birouty from Teradata. Big thanks to Krish Krishnan as well, and a big thanks to all of you out there. I hope I got to all of your questions. I know there were quite a few of them this time. But that's a good sign. It means that people are paying attention, and why wouldn't they be? This is really hot stuff. So, folks, we have one more briefing room next week with Ciro. It's also a very interesting way of looking at things, a very interesting way of running your analytical environment. So we'll talk about that next week. And we also have a show tomorrow, a new format called Hot Technologies, and it's going to have a different layout. We'll have two analysts, kind of like dueling analysts up front, and then they'll collectively take a briefing from Pair Excel after that. So we're trying out some different formats to shake things up. This does conclude our event today, folks. Thank you so much for your time and attention, and we will archive this. As always, you'll find that at InsideAnalysis.com. Take care, folks. Bye-bye.